Hey, grade nines. So now we are on the second lesson of Unit 7. Sorry, I'm just turning up the volume there. So we're going over the properties of angles that we have for a polygon. Obviously, in the last lesson, we kind of focused more on just finding the sum of the interior angles. Now we're just kind of looking at how to solve different problems that involve angles. Again, this lesson is going to be relatively short. Um, it's quite hard to actually teach this because a lot of it is almost like it's almost like puzzles, right? I can give you the theorems, but really after that, it's a matter of just kind of playing around with it. And this is one of those cases where, like a lot of things in math, the more you practice, the better you'll get at it. You'll have to see a couple more examples and try it out yourself to get the hang of it. So let's just go over a couple definitions first. So convex polygon is a polygon where all the interior angles are less than 180 degrees. And that is what the majority or the huge chunk of what we're going to cover, at least in grade 9, will be all about. So we're just going to focus on convex polygons. We're not normally going to focus on concave polygons, which is where that's not the case. Basically, you have at least one interior angle that's greater than 180. So if you have one of them that kind of breaks the rules, then it's automatically a concave polygon instead of a convex one. But like I said, this is going to be the majority of our of the cases that we look at. We're just going to look at convex polygons. It's going to be extremely rare that we look at concave polygons. And as far as I know, I don't think there's any questions in the homework that talk about that. And if they do, just ignore it because this is all you're going to see on your test. Okay, so convex polygons. So another important definition is exterior angles, and I think that we briefly saw this in the first lesson here of this unit. So an exterior angle is basically the angle that is formed by extending the side of the convex polygon. So if we were to extend this out, so again, I mean, this is already done here for you, but I can show you a different example here. If this is my interior angle, INT right here, if I actually go, if I extend this polygon line itself and I just continue it on, and it's almost like I make it just a straight line over here, I will actually see that this angle that is directly adjacent to it or next to it. So anytime you see adjacent, just next to it, this is our exterior angle. So that is what I'm referring to there. So it's just formed by extending out the side of the convex polygon there. So what's really important is when we actually can see it in this example, the interior angle and the exterior angle that are next to each other actually form a nice straight line. And this nice straight line actually adds up to one very special value. And you might have seen this in elementary school when you talked about angles. They add up to 180 degrees. So the first big theorem to understand, make sure you know this, is that an interior angle plus the exterior angle that is next to it, they add up to 180 degrees. And this is true all the time. So if we take our interior angle right here and we add our exterior angle that is next to it, they always add up to 180 degrees. So I hope that makes sense. We can look at an example that involves, and of course, now we're going to look kind of what the relationship is between interior and exterior angles more specifically. And let's look at an example here. What is the sum of exterior angles in a regular 10-gon or decagon? There's actually a special name for this one. How do we find the sum of exterior angles? So first of all, there's a couple of parts to this question. Three main parts. The first part is that you need to find the angle of the measure of the interior angle. And we actually should know how to do this based on the first lesson that we did. So we actually talked about how to find the sum of interior angles. Sorry, we know how to find the sum of interior angles, and on top of that, we also know how to find the actual measure of the interior angle if it's a regular polygon. So keep in mind there was a special formula just for regular polygons here, just to be clear. This doesn't work for if all the sides aren't the same. So the formula says that to find the angle measure, you simply take 180 times n minus 2. This gives us the sum of angles. And then you divide it by n, which is the number of sides. So this numerator right here is the sum of angles. And again, I'm just reviewing a couple things from the last lesson. Sum of angles in polygon. And it's an n-sided polygon, so for any number of sides there. And then we simply divide by the number of sides. So this is going to be the measure of the angle in a regular polygon. Okay, so keep that in mind. So that's the first thing I'm going to do. Then I'm going to find the angle, the measure of the exterior angle, and we'll talk a little bit about how we can do that. And we actually you can probably connect the dot with what we just talked about, the fact that they're adjacent to each other. And finally, we're going to find the sum of the exterior angles. So let's go step by step. Let's find the sum of interior angles first. So to find the sum of interior angles, we know it's going to be 180 times n minus 2. And that gives us a total of 1,400. And then we know from our formula that we can simply take, to find the interior angle, we take 180 times n minus 2, which is our denominator right there. And then we simply divide this by the number of sides in the polygon, which is 10. And again, the reason we're dividing it by 10 evenly is because we're told that it's a regular polygon. If we weren't told it's a regular polygon, you can't assume that the 10 angles are equal. So I hope you understand that. This is where some of the confusion comes up. People think that you can use that formula to find the sum of any angle in a polygon, but this special formula of 180 times n minus 2 divided by 10, or divided by n for the number of sides that we have, only works if it's a regular polygon where all the sides and all the angles are the same. So in this case, it is a special, it's obviously a regular polygon. So we take the sum of the angles, which is 1,440, and we divide by 10, which gives us a total answer of 144 degrees. So now that we know that the interior angle is 144 degrees, we can actually go back to our picture and kind of almost fill this in. That might be a little bit easier. If we know that this right here is 144 degrees, what we can actually do is we can go to our angle here and we can extend a line past that interior angle. And we know that this right here is our exterior angle that we're trying to find. So this is really helpful for us because we might notice that the interior and the exterior angle are directly next to each other on a straight line. So that means that the interior and the exterior angle actually add up to 180 degrees. So if they add up to 180 degrees, all I need to do is simply do a little bit of math here to figure out what do I need to add to 144 to give me 180. Well, this is really algebra, but you don't really think of it as algebra because it's quite easy math here. You're just thinking to yourself, okay, what do I add to 144 to get to 180? Well, I know I can subtract off 144 on both sides. This is just using some basic algebra here to figure out what the exterior angle is, and that means that my total answer there is 36 degrees. So that means that my exterior angle is 36 degrees. So keep in mind the question asks, what is the sum of the exterior angles? Well, what I'm going to do last here is I'm going to take my exterior angle, which is 36 degrees, and I'm simply going to multiply it by 10. And the reason I multiply by 10 is because I have 10 exterior angles. So the sum of the exterior angles is going to be 36 degrees, and I forgot the degrees there, multiplied by 10 because I have 10 angles, 10 equal angles specifically. And that means that it's going to be 360 degrees altogether. Nice thing about this is that this is actually a theorem that works for for the sum of any exterior angles. And it actually doesn't even have to just work for regular polygons. This actually works for any polygon, right? Not just regular polygons, right? And sorry, I'm just misspelling here. 1 second, let me change that. So this works for any polygon, just so everyone's clear on this. And this is this is a really nice formula because it's not limited to one type of polygon. It works for anything here. So now that we know this, sorry, just playing around with this here. Now that we know this theorem, this can help us solve a lot of different problems. So if we want to find the exterior angle of any sort of regular, if let's say we know it's a regular sided polygon and it has n sides, well, there's a nice little trick here. You can simply take 360 degrees and you can divide it by n. And again, this one is very special for only regular polygons because we know that all the sides are equal. So if all the sides are equal, then all the angles are equal, which means that I can simply take 360 degrees, which is the sum of the exterior angles, and I can divide by n, because for every interior angle that I have, I also have the same number of exterior angles, right? So all I'm doing is really just dividing by the number of sides there. So let's look at an example here. What is a measure of each exterior and interior angle of a regular 12-sided polygon? Well, there's actually two ways I can solve this. The first way I can solve this is I can actually solve for the exterior angle first. And again, I'm using this special little formula here because I am told that it is a regular 12-sided polygon. Regular meaning that all the sides are equal. So I can take 360 degrees, which is the sum of exterior angles, and I can divide by 12 because there are 12 equal exterior angles, right? So 12 equal exterior angles. So I'm going to take 360 degrees and I divide by 12 equal exterior angles, and that gives me a total of 30 degrees. Then once I know what the exterior angle is, I can find the interior angle just by subtracting off 30 degrees. And you're going to notice that sometimes I don't put the degree signs until the very end. Sometimes it's just for, just to save a little bit of time. But you can put the degree if it's an angle, but I definitely recommend always putting it at the final answer. If you don't put the degree sign during the steps, I won't take off marks for that, but just make sure that you put the degree sign when you are done the full answer there. So we end up getting 150 degrees because we subtract off the 30 degrees of the exterior angle from 180 degrees, which is the sum of the two adjacent sides. A different way I could have done this is I actually could have started with the interior angle. So this kind of goes back to what we did in the first lesson of this unit. So to find to find the measure of the interior angle here, I would simply use the formula we had from before, 180 times n minus 2 divided by n. I know that n in this case is 12, so I'm going to take 12 minus 2, which is 10, and then I take 10 and I multiply by 180 and I divide by 2. And again, in this example, I hope you can see here, what am I really doing? I'm using BEDMAS, right? So I am simply taking 12 minus 2 and I'm multiplying by 180. So I do what's in brackets first. And then this gives me 1,800, and then I take 1,800 and then I finally divide by 12, and that gives me 150 degrees. And of course, once I know what my answer is there, once I know what the interior angle is, which is 150 degrees, I can simply find the exterior angle by taking 180 minus 150, which gives me a total answer of 30 degrees. So two different ways I could have done it. I could have started with finding the exterior angle first or finding the interior angle first. Okay, let's look at a word problem here. And I apologize, I didn't mean to show the answer right away. I think I forgot to put the transitions on here, but either way, I'll explain the steps here. So our first step here is to find out what B is. And again, in these kind of problems, you're going to notice that it's not always that clear where to start. You actually have a bit of choice. You can start with either A or B. I specifically decided to start with B in this case, simply because and actually I'm just realizing something. 1 second, let me just make a change here. Okay, let's get back to the video here. Sorry, there were some technical issues there. So the first thing I'm going to do is I'm going to either find A or B, and it doesn't really matter which one you start with first. I'm just going to go in alphabetical order here. So I'm going to find out what A is first. So I noticed first that 76 degrees and A here are exterior and interior angles. This is the interior one, and 76 degrees is the exterior one. So I already know that because they are next to each other and they are interior and exterior angles, corresponding interior and exterior angles, they will add up to 180 degrees. So doing a little bit of math here, I know that I can simply take away 76 degrees from 180 to find out what angle A is, because this is the exact same thing as simply what we did in the other example, right, where we were using algebra to find the missing angle. I can just subtract off 76 degrees from 180 degrees there. So that gives me 104 degrees for my angle A. Angle B I can easily find because once again, I know that these two angles, the interior one, which is B, and the exterior one, which is 129, will have to add up to 180. So because they have to add up to 180, and I already know the one exterior angle, I simply subtract off 129, which gives me 51 degrees. So now that I know these two angles here, it's getting a little bit easier. This is 104 degrees. This is 51 degrees. So now I have to figure out what angle C is. So to find out what angle C is, I'm going to notice that the shape inside, and let me just erase this so I can just focus on this right here. The shape that is inside the main polygon that we're looking at here is a quadrilateral. It has four sides. So because it has four sides, we know that the sum of the angles will simply be 180 times n minus 2. And in this case, the n is 4. So we're going to take 4 minus 2. And we know that 4 minus 2 is 2. So 180 times 2 is 360 degrees. So that's how I know that the sum of a quadrilateral, any four-sided shape, is 360 degrees. And I keep in mind that this formula works for any polygon, right? This isn't a special formula just for regular polygons. It works for any polygon. So this is one of those sum of angles that you should definitely try to memorize because it comes up enough times that it's worth just memorizing it, right? So sum of angles in a quadrilateral is 360 degrees. So now that you know what the sum of angles in a quadrilateral add up to, and I already know what the two angles here are, right? This is 104 degrees and this is 51 degrees. I can simply subtract off all three angles that I know from 360 degrees. By the way, how do I know what this angle is in the corner here? Well, it's right. I see a little symbol here. Basically, it looks like a little box. I know that that represents 90 degrees there. So hopefully you remember that from elementary school. I automatically know that that's 90 degrees. So all I'm going to do is subtract off the three angles that I do know, which is 104, 51, and 90. I'm going to subtract them all the way from 360 degrees. Or I can add them up and then subtract them from 360 degrees. So doing a little bit of math here, double check that it's all correct in the calculator if you don't mind. 104 plus 51 is 155, and then we add 90, so we get 245. That seems correct. So 360 minus 245 gives us a total answer of 115 degrees. And one really important thing when you're looking at your answer, always make sure that it makes sense with the picture given. Keep in mind that the textbook is not drawn to scale. So obviously, you should not be using a protractor to check the actual answer. It's not going to be exact. They don't draw it exactly to scale. However, the book does try its best to always give reasonable answers, if I'm not mistaken. I don't think there's ever been an issue with that. So, for example, if I had gotten an acute angle, so an angle that was less than 90 degrees, that wouldn't make sense with my picture because I can clearly see here that C is obtuse. And if you recall from elementary school, an obtuse angle is an angle that is greater than 90 degrees. So because it's an obtuse angle, it looks obtuse, and then I know my angle should be also greater than 90 degrees. So the fact that I got an angle of 115 degrees makes sense. And it also shouldn't be too big either, right? If I had gotten an answer of like 170 degrees, that's way too big. So it wouldn't make sense with the picture either. All right. So let's look at a couple of the angle theorems. There's basically two different parts I want to split it up into. The first part of the angle theorems is actually what you've seen since elementary school. So I'm going to go over this pretty quickly because you're probably quite familiar with this. So the first part of the angle theorems basically goes over what happens when we cross two lines. So if we cross two lines or two rays, we'll notice that the opposite angles are equal. So in this case, angle A is equal to angle B because they're right across from each other. And so is angle C and angle D. They're also equal to each other. And they kind of, you can see it yourself, they are equal. Supplementary angle theorem, or SAT, sometimes for short form, says that the sum of adjacent sides on a line is 180 degrees. So if I take two angles that are next to each other on a line, on a straight line, they're going to add up to 180 degrees. And complementary angle theorem says that the sum of adjacent angles in a sharp corner, and we kind of know what that means now because we saw it in the last example. If we see that they add up to, they're inside of a sharp corner like that, we know that that's equal to 90 degrees. So if there are two angles inside of it, then we know that the two angles add up to 90 degrees. So for example, if I had this angle A and this angle B right here, I know that angle A and angle B have to add up to 90 degrees. And sometimes instead to specify that we're talking about an angle, we normally will use the symbol angle, like a little angle symbol there. You are going to see that you're not going to use it as much in high school, but it's still a good symbol to use, right? So if you ever want to use that symbol, you're absolutely welcome to do that. So I hope this all kind of makes sense. Again, this is mainly review from elementary school, so I'm going to skip over this a little bit faster. The angle theorems, the second part of it, these are more special theorems that we have if we have parallel lines that are cut by a transversal, which is basically just a straight line that goes through it. So what this is we kind of notice a bit of a pattern with the angles that result from this transversal going through the parallel lines. So again, key word here, we need to make sure that they are parallel lines, right? So for example, this angle A right here, we can even see it visually, is equal to angle B that is right underneath it. And this angle right here on the corner is equal to this angle here at the corner as well. And this is called the Z pattern because it kind of follows that pattern with the actual, when we actually draw out the equal angles, it kind of looks like it creates that letter. The corresponding angle theorem basically says that angles that follow a F pattern are equal to each other. So these two angles are equal to each other. These two angles are also equal to each other, creating an F like that. And moreover, if I were to take this angle over here and this angle at the bottom, they are also equal to each other as well, creating an F pattern. And the last one, this one's a little bit different. Co-interior angles basically means that the two angles that are inside of, in between two parallel lines add up to 180 degrees. So these two angles add up to 180 degrees, and these two angles also add up to 180 degrees. And it's called the C pattern. There's C rule, sometimes there's C pattern, because it creates the letter C. So I'm hoping most of this is review from grade 8, but if this is totally new, please review the handout that I posted on angle theorems. I'm not going to necessarily test you on the names. I don't think I'll ever ask you for the specific names of the theorems. Just be aware of them and be able to identify the theorems so you can use it to solve different problems. All right, let's look at another example. And in this one, we're going to use a little bit of algebra. So we first of all notice that, well, we're asked to find the value of x, which is a bit strange because this kind of seems like algebra. Well, you're going to use algebra. So I first realized I have a four-sided shape. So I have four sides here, 1, 2, 3, 4. So I know that in the four-sided shape, the angles will add up to 360 degrees. That's the first thing I'm gonna note here. 360 degrees is the sum of all the angles here. Well, what do I do if I had numbers? Well, if I had numbers, I would simply add the angles up, and I would make it equal to 360 degrees, because I know that that's what they add up to. Well, the only difference is that I don't actually know the values of the angles, but I can still follow this in the same way. I'm going to take each of the interior angles, even though there are variables, and I'm going to simply add them up together to give me 360 degrees. Notice that I'm putting brackets around the angles, and the reason for this is because I'm specifying that this whole entire expression, x minus 40, is one of the interior angles. So I'm kind of piecing it together by putting brackets around it. So I know that if I add the four interior angles, they're going to add up to 360 degrees. What do I notice next? Well, this is just an algebraic expression where I have like terms. So because I have like terms, I know that I'm allowed to add up the like terms together. So I add up all the x's together, and I add up the numbers together. And this ends up giving me 4x minus 70. And how did I get 70? I just added the numbers together on the left-hand side. Negative 40 minus 30 gives me negative 70. And my next step here, and I know I'm skipping a couple steps here because I'm assuming you guys are definitely becoming pros with algebra. If I want to move the negative 70 over to the other side, I know I have to add 70. And if I add 70, that means that the 70 on the left-hand side is gone and moved to the right-hand side. And now I end up with 4x is equal to 430. And of course, 400, to get the x by itself, I simply take 4x and then I divide by 4, and I divide 430 by 4, which gives me 430 divided by 4. And I did not actually solve that for you, and I wonder if I just got a little lazy there near the end. So 430 divided by 4 ends up giving me 107.5 degrees, and that is the value of x. Now, keep in mind, I'm actually not done with this question fully if it had asked me to actually find the interior angles. In this question, it actually was pretty easy because it just asked me for the value of x. If it asked you for the interior angles themselves, not only would you have to solve for x, you would also have to figure out what the rest of the interior angles are. So I know that this is 107.5. And then to find this interior angle, I just take 107.5 minus 30, which would give me 77.5 degrees. And of course, this one is 107.5 degrees minus 30 degrees, which gives me 67.5 degrees. So that's all I would have to do to find the other interior angles. So I hope that all makes sense there. And a good check, maybe double check that they all add up to 360 degrees, which I can quickly double check, but I already know that this is making sense so far. And yes, they all add up to 360 degrees, so that's correct. All right, last question here. How do I find the angle X here? So what I'm going to do in this case is I'm actually going to try to see if I spot any patterns that we talked about from before. So first thing I notice is that I have equal sides. And because I have equal sides, that means that the corresponding angles will also be equal. So if these two sides are equal, that means that this angle right here is equal to this angle right here. So I already know that right from the beginning. Now, how can I use that to my advantage? Well, this is definitely going to be used when I'm finding out what the angles are here, what the angles are inside of this triangle in between the two parallel lines. But what I'm going to notice next is the fact that the two parallel lines actually create some of the patterns that we discussed. Specifically, it creates the Z pattern. And we notice that the 30 degrees right here in the corner will be equal to this angle right here, which actually includes two kind of sub angles, I guess you could say. Now this little symbol right here with the dots, what they mean is that the angles are actually equal to each other. So that means that the angles are equal. So doing a little bit of math here, if I know that this whole entire angle is equal to 30 degrees, and how do I know that? Because we follow the Z pattern. If I know that this whole angle at the top there is 30 degrees, then that means that because these angles are actually equal to each other, this is basically dividing the angle 30 degrees in two. That means that the orange little angle right there is equal to 15 degrees. So if this right here is 15 degrees, then I know that this angle, which is equal to it, is also 15 degrees. And we're getting closer and closer to the final answer here. So what I'm going to do just to kind of help us see this a little bit better is I'm almost going to redraw this picture just so I can focus on what I need to focus on here. This is 15 degrees. This is 15 degrees in the corner, and I know this because the two corresponding sides are equal to each other. Corresponding sides just refers to the sides that are opposite of the angles. And remember, the question was asking me for angle X, which is right here in the corner. So how can I find angle X? Well, I know that this is a triangle, and we know that angles in a triangle add up to 180 degrees. So that means that angle, the 15 degrees in the corner, plus the other 15 degrees in the corner, plus X is equal to 180 degrees. I look at this and I say, all right, well, I know how to do this. This is just a simple equation that I can solve. I add this up. This gives me 30 degrees plus X is equal to 180 degrees. My next step, take away 30 from both sides. And I end up with X is equal to 150 degrees. So that means that X is equal to 150 degrees there. So notice that a lot of these questions are almost like puzzles, right? You have to just start with one step at a time. Don't get intimidated. Start with the easy parts of it. And if you go step by step, you should be good in finding all the answers there. So best of luck with the questions. Most of the questions are relatively easy. Some of the ones near the end get a little bit trickier, but I have faith in you guys and I know you can do this. All right, best of luck.